Thank you very much, John, and good morning to everybody. I guess it wouldn't be really a real hybrid event if not one of the speakers was online, and this time it's me who is doing that. So I would still have to go through the classic by now. I hope you can hear me part. And yeah, as I said, as John said, my name is Nikos Cutululis, and I'm from DTU Wind Energy, and I'm in the management board of EERA GP Wind, coordinating the sub-program on system integration, which probably makes it more clear why I'm going to address the third grand challenge, which is related to the integration of wind power plants in the future electricity grid. And I hope you can see my slides, that the slides are ready and can be shown. Yes, so as I said, the third grand challenge is the system science for integration of wind power plants into the future electricity grid. And of course, as with the two previous one, our job here was to try and see what that means, or how this applies to the two direction for the Lighthouse initiatives on the floating wind and the integration of offshore wind. So if we move on to the next slide, yeah, this you've seen it quite a few times, so I think we can move on a bit faster on that. But when we talk about offshore wind, I think on the next slide, one of the main points that was discussed, and also this morning, was the very high ambitions that we have in Europe. Yes, related to offshore wind. It could be 300 gigawatts or 450 gigawatts. It's really not that important. Both numbers are extremely high. But when we talk about this, one important aspect that we need to take into account is how we're going to connect how we can connect all this offshore wind, be it bottom fixed, be it floating wind, how we're going to connect it to the power system. And if you can please move on to the slide. You would see here, if we continue the way we are doing it today, where pretty much, with very, very, very few exceptions, pretty much every single project is connected to shore with its own dedicated line. If we look at 200 gigawatts of offshore wind by 2050 in the North Sea only, we will end up with this maybe kind of clumsy drawing that I made, but hopefully it conveys the message that it will be a very not cost efficient way of doing that. And since there was a big discussion about that, probably the environmental impact of this will be extremely high. So one of the main points of discussion, and where more research and developments are needed, is how to connect all this offshore wind power to shore. And of course, the challenge it increases with the distance. So maybe floating wind, it's even more pronounced than that. But in general, we need to move to a different way of connecting offshore wind to the grid. But and we move to the next slide. But we cannot look at, when we talk about system integration, and we cannot only look at offshore wind in isolation, but we should also look for the rest of the power system. And in this depiction illustration here, you can see a possible, probable, and desirable evolution of the Europe's power grid, where hopefully we will go to a system like the one to the left, where there was almost no renewable energy sources, and you had a system like where we are today in the middle. Mostly at least in the Northern Europe, we have a system where we have more and more renewable energy generation, and you can see the offshore wind is also depicted there. But not only offshore wind, we have onshore wind, of course, we have PV in the generation side, but we also start having more and more loads that are connected through power electronics, like the electrical vehicles. But we should not forget that our target is really to move to a system like the one in the right, which is called 100% RES. And this we can call it different ways, but the main idea is that we will have many more renewable energy sources connected or being part of the grid, or being the grid. And in that sense, maybe integration into the power system, it's not ambitious enough. Maybe we should consider moving from integration to transforming, because I think moving to a system like the one in the right is truly transforming it, not just integrating it with additional type of sources. So when we did the workshops, like the two other presenters, we had a workshop trying to get more ideas on how the third grand challenge of wind energy is applying to floating wind and to massive amounts of offshore wind into the system. We try to keep in mind those two aspects. So if we move to the next slide, I've also used a bit. I'm sorry for the quality, but I hope you can see on the left side are kind of the two topics that we identified from the different research agendas that came up. And again, thank you to Peter and Van William for putting this up, like for the other. But a big part in that was related to the grid and cabling in offshore, in floating wind farms. So how we gonna move to floating cables or dynamic cables, but also on floating transformer stations. And you can notice that these are very much kind of part of balance of plant, which of course it's very important topic. But also in the discussions that we had in the workshop, we expanded on some of the topics, and some of the extra parts that came in was to look at the environmental impacts of the submarine cables, but also on the mobile seabeds, the scour, and then based on that, on the scour protection. And of course, maybe it's going to become obvious that not everything here it's related to floating wind exclusively, but there are topics that are for interest, both for bottom fixed and floating. But maybe now it's an opportunity to expand and really develop those methods. Then it was a topic about actually subsea technology, not only floating. Yes, the wind turbines most likely will be at the placed on the floating on the surface of the sea, but maybe some of the other components like transformers or substations or HVDC converters, if we move into DC transmission, maybe some of them will be better to have them as subsea technology. And that was one topic too that came up, and I think it's important. Then the same about the modeling part was one of the topics that came up is to create reference integrated models and use cases for floating wind. And finally, maybe also important is to distinguish between medium and very deep waters. And this has, of course, will have an impact on the wind turbine, the floater, and the mooring system, but also can have a big impact on the grid connection. So the cablings and the grid connection of floating wind. I added my own note here because it may seem like there are not really many topics that came out on floating wind from this workshop, but I think this was partly because we tried here to discuss what is kind of very interested and very focused on floating wind. But when we talk about integration, of course, applies, as I said already, to everything, not only floating or bottom fixed, but also to floating wind. So some of the topics, or quite a bit of the topics, are overlapping. So moving on, then I think. This is the vision for the Lighthouse initiative. I think we will discuss that in the next presentation. So if we move on a bit fast on that, we are coming to the second Lighthouse initiative, the integration of large scale, really large scale, truly large scale, massive scale of offshore wind into the future energy system. And can you please change the slide? Thank you. And here, some of the topics that were discussed was again about grid and cabling, and I will not really go on to the each individual topic here, but the main idea is that the electrical infrastructure, balance of plant when it comes to individual power plant, but also the transmission and probably the development, hopefully the development of an offshore grid it's something that needs to be addressed, and there are steps taken into this direction. But there's still a lot of research to be done in the transmission technology for offshore grids, but also into other aspects like controllability and so on. And of course, sustainability. It was discussed, and it's a very relevant and important topic, but maybe was not very present in our discussions. But I think we should always have this at least kind of in the back of our head when we are discussing about this part. And then the second topic here, I think it's related to what I tried to show, that we cannot see this in isolation, because having the system, the power system, future power system is changing, and is changing very fast. So offshore wind will be only part of it, but we need to look at what is the role of offshore wind and how offshore wind will be the cornerstone and will contribute to this 100% RES power system, and what are the requirements or the expectations from generators in that kind of system. I think some of the topics that came up was here to design and control for 100% RES in terms of energy management, but also in a bit more in a different time scale, much faster time scale, to discuss about low inertia power system and what will be the requirements for the system stability in this context. Then the next topics that were discussed, and there on the next slide, was quite broad, I think: control, regulation, and markets. And I will, of course, regulation is extremely important, because very few things will happen if the policy and the regulations are not designed for it. And of course, we need markets to have these projects being profitable, so they will be built. But maybe from a research perspective, control is becoming extremely important, because as I said, we are looking at a system, a future power system that is very, very different than the one we operating today. And control of offshore wind, but also onshore wind and PV and loads and everything else, it's becoming much different than today. So control will be one of the main topics, and how we develop, what are the requirements, and how we develop the control capabilities from offshore wind, in this case, to meet those requirements. And then finally, the second part is about hybrid solutions. So one way to actually be able to meet those requirements would be to move to a hybrid solution. I think this morning was also discussing about offshore PV. So why not offshore hybrid power plants, which will combine more than one generation technology, but also combining other solutions like power to X. So maybe some of the electricity will not even be transported to shore anymore, but will be used locally to produce or to convert it to molecules. So this is another topic, very big topic that should definitely be included when we are looking at such a broad and large initiative for integration of wind of offshore wind into the power system. And I think this is reflected in the last slide here of my presentation, which is the kind of the vision about the integration of large-scale offshore wind energy. And again, I will think, also in interest of time, I will stop here, because this is actually coming up in the next presentation. So thank you very much, and I'll be glad to answer any questions.
Thank you. So questions for Nikos are very welcome. One from Arno van Winnegen.
Please.
Yes, thanks, Nikos, for a very interesting presentation. I'm still worried when I hear all these questions, all these things to be answered. Is there any kind of, even on an academic level, like a strategy for like, okay, and this, of course it will change, is more or less the kind of grid we want to see in 2050? Or is it more like the one slide you drawn where at the moment everybody plants a farm, gets their energy to shore somehow, and then, well, kind of hook up the whole thing more or less together. So is there like a pan-European strategy for this kind of stuff developing?
I think there is more and more consensus on the fact that we need to move from planning for each single project to an integrated design or more integrated design for an offshore grid, if that's the question, if I understood it correctly. That is definitely something that is coming up, and it is on the agenda, and the first steps towards that are already being taken. But we need to be able to do more on this direction. So I think it's a bit more than academic level today, but we need the underlying knowledge to do it properly.
Yeah, definitely. But I've yet to see a kind of really European plan like this, more or less, is the grid we envision for 2050. Of course, it will always change according to whatever wind farms, solar farms, whatever the heck are being built. But so far I haven't really seen much.
Okay, I think then it's probably partly my fault because I didn't disseminate that very much in this group, I guess, because we've done offshore grid design quite a number of times, and there are quite a number of even blueprints of how this grid will develop. I don't think, as you say, everybody knows that these things will change, and they are changing. So, but there are already some indications or tendencies or even agreements on how to do that. I think we just need to disseminate it a bit more.
Okay, thanks.
Yeah. So. Thank you. I'd like to add maybe to your question, Arno, that the question you ask is exactly one of the reasons why it's important to have a research project on this, because, okay, there are lots of pictures and drawings about how the offshore grid will look like in the future. Lots of them. And also visions about how the system should be operated. But the thing is that we don't have one dictator on the top who says you should build it like this. So whoever has an opinion are in his or her full right to have so, and developers can develop their projects according to frameworks and so, but there's no sort of overall golden plan, I would say. And of course, this has to be developed based on knowledge, the best knowledge. So that's why we need the research to really investigate all these options and really sort of look into the crystal ball and say, okay, this is probably the way to do it, respecting also that this is a highly dynamic process with lots of actors that you don't really control, and how should sort of the boundary conditions be developed to ensure this. So I see we have one question on the... Two questions on the chat. Let me see. Oops. So first one is from Paul McKeever. He from our Catapult, and he asks, Nikos, you presented a 100% rest diagram with nuclear power removed. Is this aspirational, or do you see this as a firm goal?
Short.
Yes or no?
Very good questions. I think it's definitely aspirational now at this point. I don't think it's a firm goal, but it's a very long discussion, so I wouldn't go now into this.
I would maybe say that JP the wind community should mainly focus on the wind stuff, not really decide on nuclear. And then the next one is from Mikael Ibras, who asks, how do you think new electrical markets should or not guide our research due to the large integration of renewable energy sources? Sorry.
It's another very good question. I think it's probably will be a combination of technology push and market push. So I think they will have to kind of move in tandem, and we have examples of both. So the markets are trying to adapt to the way technology is developing, and here I'm seeing it from a more general perspective of renewable energy RES power plants, which have different marginal costs than conventional power plants. But also we see from the fact that the more having more renewable energy plants in the system will also probably push the price down. So maybe the energy only or the energy markets as they are today are probably not optimum for the future, with the disclaimer that I'm not really an expert on markets. And in that sense, then when you look at this market impact on that, developing new technologies, like I think low wind is a project, or low wind technology, wind turbines that will produce mostly or almost exclusively in the low wind periods when the prices will be expected to be higher, is another example of, or it's an example of this setup or the influence that the prices and will have on the technology. So I think they are going hand in hand in a way. But with my technical background, I would say I would put more focus on technology, but I may very well be wrong on that.
Okay, then we have a question from the audience. So Ignacio, if you state your name.
Yeah, this is Ignacio Martí from DTU Wind Energy. Coming back, Nikos, to the 100% target on, or let's say, scenario for renewables. This recalls a discussion we had some time ago, or is a kind of recurrent discussion in the IEA Wind Executive Committee, where some countries have mentioned explicitly that we should not go for a 100% renewable scenario. And I'm saying this because it is maybe an opportunity for the research community to really show scenarios that are possible, or let's say, what does it take to go to 100% renewables, and maybe other scenarios as well. So, I mean, on top of the political discussion, which is a different thing, I think part of our role here could be to show the way, what is possible, and then, okay, others will make choices. But I think we should be ambitious. If we are not, who is going to be ambitious?
I fully agree with that. I fully agree with that, and that was my message. That yes, we're talking about system integration of large-scale offshore wind, but I think we should be a bit more ambitious than that, or of course keep this framework. But in this framework, we need to look how the system will evolve, and that's it's not only offshore wind; it's the total, it's the whole system, and I'm not sure why we should not have the ambition or aim at 100% RES. Maybe it's a definition of RES, that what is RES that hinders this. But anyway, that's a different topic. But yes, I fully agree that we need to be more ambitious than that, and the solutions that we are developing, especially in the control part, would definitely show the way how to do that. On more energy topics, maybe this is not going to be part of the Lighthouse initiative very prominent, but it's also something that we could say we could have an opinion about. I agree.
Very good. I think we have we are a bit behind schedule, but I understand at least here in Amsterdam we don't have anything on the program before lunch. So well, we can spend a few more minutes, I guess. So, but this will be the last question for this session, and then we go on to the last speaker for this session after that. So, but this is from Feike Savinje. I'm sorry if I don't. Savinaya. Okay. It reads, Dear Nikos, thank you for the overview on system integration challenges. What is your view on connecting the topic of hybrid/off-grid solutions to floating wind application?
I think they are both hybrid or off-grid solutions are very relevant topics and topics that will most likely become more and more present on the research agenda and the development in the future. And at least onshore, the hybrid is it's an extremely active and current topic. I would think that they will also become a topic for floating wind application, both of them, a hybrid, maybe off-grid, a bit more if we take into account the fact that this might eliminate part of the cost related to the grid connection. But I do think that they are, when they come, they will be probably a little further down the line with other topics actually making floating wind in itself competitive commercially and available commercially and driving the development. It's probably a bit before we should move too much towards off-grid solutions, for example. So let's produce electricity and use as much of it, electrify first, and then look at the second part. Would be my answer.
Okay, very good. So thank you again, Nikos.
Thank you. And we also have a session on Wednesday, so I'll see you, most of you or all of you, hopefully in Amsterdam in the next days.